Wheatstone bridge. Let us consider 4 resistors R1, R2, R3 and R4 are connected to each other along the sides of the rhombus with vertices A, B, C and D. Now, in order to explain this, what I'm going to do, I'm going to use this information to draw a figure, and my figure is right here, where you can see this is my external source of the battery or the power, and I ampere of current is passes through the circuit, as well as I ampere of current is leaving the circuit too. Now, let the resistance across the arm AV is R1, across BC is R3, AD is R2, and across DC is R4. And the current passes through ABC is I1, and the current passes through ADC is I2. As we can see, the current passes through the diagonal BD is 0 because there is no current passes through the galvanometer. That's why Ig, which is the current passes through the galvanometer, is 0. And this is the condition for the balanced Wheatstone bridge, which simply means that if the Wheatstone bridge is balanced, then there will be no current passes through the galvanometer. Now, let us consider that the current I passes through the battery, and at point A, the current is divided into I1 and I2 respectively. So as we can see, the I ampere of current passes through all the way to A, but at point A, the current I is divided in I1 and I2. Now, let's use the Kirchoff's law for loop ABDA. ABDA, this part of the circuit. And if we use that, we will write negative I1 R1 plus I2 R2 is equal to 0, because the current is passes through here, so the direction of current is this. And for this part of the circuit, like arm AD, the current is passing through this direction, but we are taking the loop like this, so I1 R1 will be negative and I2 R2 will be positive, or vice versa. And if we do that, we will write negative I1 R1 plus I2 R2 is equal to 0. Let's simplify, and if we do that, we will get I1 R1 is equal to I2 R2, and let this is our equation number 1. In the same way, let's use the Kirchoff's law for loop BCDV for this part of the loop. And if we use the Kirchoff's law for this part of the loop, we will write negative I1 R3 plus I2 R4 is equal to 0, which is right here. Let's simplify further, and if we do that, we will get I1 R3 is equal to I2 R4, and let this is our equation number 2. Now, next thing we will do, we will divide equation 1 by equation 2. So let's divide equation 1 by equation 2, and if we do that, we will write I1 R1 over I1 R3 is equal to I2 R2 over I2 R4. As you can see, I1 is common on the left side and I2 is common on the right side. So I1 will cancel from the left and I2 will cancel from the right. And if we do that, we will write R1 over R3 is equal to R2 over R4. Now let's simplify further, and if we do that, we will write R1 over R2 is equal to R3 over R4. And this is the equation when the Wheatstone bridge is balanced, which simply means that there is no electric current passes through the galvanometer. And this is how we'll define the Wheatstone bridge and also the balanced Wheatstone bridge.